e to the x. So let's find the Maclaurin series of this function e to the x and its radius of convergence. So you see the phrase Maclaurin series, which means I'm taking a to be 0. Anytime you see Maclaurin series, that means you're doing a Taylor series about 0 or at 0. So let me kind of go back up a little bit. This is what we need to write, is this power series representation. So in order for me to write that, I need to find a formula. I need to understand what these coefficients are. These coefficients right here, what are they? So there's a lot that goes into computing these coefficients. I have to take derivatives of my function. I have to plug in 0. I have to divide by n factorial. So what I do is I organize this into a nice table. Okay. So I'm going to make it this table. It's going to have 4 columns to it. So n is going to represent 0, 1, 2, 3, which term I am on my series. And then I'm going to take nth derivatives. I'm going to plug in a, which is 0, into that. And then the last column is my coefficients. I divide by n factorial. So you can really think that like each column, you build on the previous column. So let's start with the first one. I'm going to take my function, which was e to the x, and I'm going to take derivatives. So when n equals 0, that means that I'm not taking a derivative, so it's just my function e to the x. And as you go down in the table, you're going to take derivatives of the previous line. What's the derivative of e to the x? E to the x. So happens to stay the same. Take another derivative, e to the x. Another derivative, e to the x. So luckily, those all stay the same. E to the x is a really nice function. So now you're going to plug in 0 into x for each one of these. So I get e to the 0, which is 1, 1, 1, 1. So now I'm going to take my third column and I'm going to divide by n factorial. So for the first one, you're going to have 1 over 0 factorial. The next one, you're going to have 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial. Now you can simplify these if you want. You could write 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6. But what we need to do is we need to come up with a formula in general. So usually you don't want to simplify in this last column. So let's see what's going on here. Let's write out our terms for our series. So this first term here represents my constant. So I'm going to have 1 over 0 factorial. And then this next one, this is my coefficient in front of x. So I'm going to have 1 over 1 factorial times x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed, and so forth. So all I got to do is figure out the pattern and write the formula down. Do you notice a pattern? Yep, exactly. The factorial matches my power on x. So this is going to be 1 over n factorial x to the n. N starts at 0 to infinity. And this is going to be your power series representation, your Maclaurin series that you were looking for your function, e to the x. Okay. So I've answered half the question. I wanted to find the Maclaurin series, and I did. What was the other question that was asked me? Radius of convergence. Now for these, we're not basing all of our information on the geometric series anymore, which means I have to revert back to how I found radius of convergence before. We found it through the ratio test. So we're going to have to use the ratio test here. Okay. So let's do that. Use ratio test to find radius of convergence. So we take the limit as n goes to infinity, an plus 1 over an. So everywhere there's an n, I replace it with n plus 1. 1 over n plus 1 factorial, x to the n plus 1. And then I'm going to divide by, so I got to flip it, n factorial over x to the n. We saw a lot of this before our exam. We group up our like terms together. X to the n plus 1 over x to the n factorial, n plus 1 factorial. And then you simplify. What am I going to get if I simplify here? What do I get for the first fraction when I simplify? X to the 1, x. And then those factorials, do you remember how to simplify the factorials? Pull out, rewrite this guy as n plus 1 times n factorial. And now the factorials will cancel. So you're left with 1 over n plus 1. Remember, x is a variable, so it could represent a negative number, so it has to stay inside of the absolute value. But I can pull it out in front. The limit as n goes to infinity, 1 over n plus 1. Limit of 1 over n plus 1. What's that? 0. So I get 0, which means I'm getting 0 for this limit. Now here's the part where, remember, when you do these tests, you stop after you're done with your calculation and think about what the test says. I got a 0. That's a number less than 1. So what does the ratio test tell me? My series converges. Anytime I get something less than 1, it converges. So it turns out it doesn't matter what x is. This thing is always going to converge. So your radius of convergence here is going to be infinity. Because no matter what value of x I plug in, I'm always getting 0 for this limit, which is always less than 1, so it always converges. Okay. So again, we are going to rely heavily on our previous knowledge In particular, the ratio test is really important for these questions where I'm trying to find radius of convergence. Okay.